Well, Math 3A, we must be close to the end of the class because we're now doing integration. So you'll be using the antiderivatives to find some exact values like number 2 right here, and then also the Riemann sum to estimate the area under the curve. So for my first example, so the function itself is 1 over the square root of x going from 1 to 4. So this basically means find the area under the curve as x goes from 1 to 4. And first, use the Riemann sum with the midpoint of 9 rectangles. So the first thing to do is find what's called delta x. So you find the length of the interval from 1 to 4. So subtract 4 minus 1. That's going to be 3, of course. And then however many rectangles it says to use, then divide by that number. So it's going to be 3 over 9 or a 1/3. Then the next thing I do is I just look at the number line from 1 to 4 and say, okay, we're supposed to go from 1 to 4, and then you go over by 1/3 each time. So when you start at 1 and you add a 1/3, then that's going to be 1 1/3, also known as 4/3. Of course, you could go like this and say 1 plus a third, and then go to math, find out the fraction, that's 4/3. So this is the first interval. Then I also need the last interval. So from 4, I actually need to go to the left by a third. So if you subtract 4 minus a third and get that fraction, that's the 11/3. Okay, so now I have the first interval and the last interval. The next thing is find the midpoint. So now I need to find the midpoint that's halfway between a 1 and a 4/3. So what you can do is just add these two numbers together and divide by 2. That's the midpoint. So I do need to put parentheses and then 1 plus a 4/3 and then divide that by 2. And then to make me look smart, I'm going to tell the calculator, what fraction is that? 7/6. So this one is 7/6. And then find the midpoint between the 11/3 and the 4. So I need a paren and then 11/3 plus 4. That gets divided by 2. And then get the fraction is 23 over 6. Okay, then I can have the calculator find this Riemann sum for me. So hopefully you've seen this before in the lectures. You go sum the sequence. And basically what's happening is we're going to take this number 7/6 and plug it into the function and use that as the height of the rectangle. And then the width is delta x, 1/3. So the area of the rectangle will be the function 1 over the square root of x coming from the integral. And then that's going to be the height of the rectangle. And then times 1/3 the width. Tell it that we're using x as the variable. And then it's going to start at 7/6 and end at 23/6. And the last thing to always tell it is the delta x. All right, then to input that in the calculator. So this is a list operation, so you do need to go to second list and then move over to math, and here's the sum. And then go back to second list, go over to operations, and then here's the sequence. Now, depending on the age of your calculator, like the newer operating system have this little table, so you would just go 1 divided by the square root of x. and then times 1/3, and then tell it that the variable is x, and then it starts at 7/6, it ends at 23/6, and the step is always the delta x, so that's a 1/3. And then put paste. If you have an older calculator, then it would just expect you to type this in yourself with commas in between. So the sum sequence, and then here it is with the commas, you just type it yourself. And then the final answer is a 1.998. So party like it's 1998. All right, then part B, find the exact value. So find the antiderivative. So in order to find the antiderivative of this, I'm going to rewrite the square root as x to the 1/2. And then because it's 1/, that means x to the negative 1/2. So the first thing is integrate from 1 to 4 and then rewrite it as x to the negative 1/2. I forgot to put dx. Hold on. There we go. And now just get you a red pen, and to find the antiderivative, add 1 to the exponent, which is going to be a 1/2, and then you divide by that number. So that means that the antiderivative is going to be, well, when you divide by a 1/2, you could invert and multiply, so that's going to be 2/1, or just 2. And then this is x to a 1/2, positive 1/2, which means square root. And then evaluate that from 1 to 4. And our answer should be close to 1.992. If we get the answer 13, probably did something wrong. It should be close to 1.998. All right, so substitute the 4 in first of all. So it's going to be 2, the square root of 4, minus 2, the square root of 1. And this is going to be, well, this is a 2 times 2, so that's 4. And then minus 2, so the actual answer is 2. So our estimate of 1.998 was not that bad, only off by 0.002. All right, then I also wanted to do some u substitution. So on the second page, I even emphasize, make sure you say what u and du are equal to when you use u substitution. So for this one, this sine function got substituted into the e function, and that's basically what u substitution does. Is it's basically trying to figure out how did somebody use the chain rule. So I'm going to let the u equal the sine x, and then because I have my derivatives memorized, I know the derivative of sine is cosine x, and technically this side would say du over dx. And then the next step you multiply by dx. Well, because that step is exactly the same every time, I just go ahead and skip it and say, I know I'm going to multiply by dx and have it on this side, so I just do that in this step. And then if you notice, cosine x dx is exactly what this says, so this whole thing gets replaced with du. And this is going to say e to the u, so it's going to be integrate e to the u, that takes care of the sine x, and then replace the cosine x dx with just the du. So this is now saying find the antiderivative of the e function. Since the derivative of the e function is itself, the antiderivative of the e function is itself. And then because there's no numbers to plug in, we put plus c, the constant of integration. And then the last thing to do is just replace the u with sine x, and then we're done with that one. So e to the sine x plus c. And then if you take the derivative of this answer, it's going to be that function. All right, then one more. So my first idea is that I should let the u equal the bottom part. So whenever you have a fraction, it's probably a good idea to let the u be the bottom part. So for example, this one, I probably would not let the u be the whole thing, the square root, but I would probably go with that the u equals 9 minus x squared. And then the reason for that is because when you take the derivative of 9 is 0, of course, and the derivative of negative x squared is negative 2x dx. And this has 2x dx, and this has 2x dx. So they're matching, other than a negative sign. So you just need to move the negative to the other side and then do the u substitution. So I'm going to try something similar right here. Let the u equal the bottom part. So u equals 1 plus cosine. And now take the derivative. So derivative of 1 is 0. Derivative of cosine is negative sine x dx. And just like the one I was just showing you, this matches the sine x dx exactly, except for the negative. So just multiply both sides by negative 1. And now we know what sine x dx gets replaced with. So that means this part is going to become negative du. And with a negative, you can just factor that out. You could leave the negative right here on the du, or you could factor it out either way. And then the bottom part just becomes u. So this is basically like having negative integral 1 over u du. So 1 times du is just du, means the same thing. And the antiderivative of 1 over something is the natural log. So it's going to be negative the natural log of u, and then put the plus c. And then finally replace the u. So it's going to be negative natural log, and then the u is equal to the 1 plus cosine of x plus a c, and then it's done.